Hello everyone, welcome to the channel. In this video, you will learn about the two-phase separator and mist eliminators. Separators and mist eliminators plays an important role in any process industry to ensure the reliability of equipment and production enhancement. Separators are pressure vessels designed to separate gas liquid or gas liquid solid mixtures using gravity, residence time, and mechanical devices. They are installed at upstream of critical equipment like compressors, flare systems, and scrubbers. Primary functions of the separators are to prevent liquid carryover, protect downstream equipment, improve process reliability and safety, recovery of lube oils, solvents, hazardous mist, protection of turbo equipment, and pipeline hydrate inhibition. Working principle of a separator is based on the drag force overcoming. In separator, droplet size is increased to enable gravitational drainage by overcoming the drag force. In this way, the heavier liquid settles to the bottom while lighter gas rises to the top. The operation of a separator happens in a sequential stages. In first stage, primary separations occurs where the momentum of the inlet stream is reduced by hitting at inlet diverter or baffle plate with high velocity. This sudden change in direction causes a rapid drop in the momentum. While in second stage, gravity settling happens and gravitational forces overcome by a drag force to settle the droplets. In third stage, liquid collection occurs through settling and stilling, where baffle plates are used to reduce turbulence and increase settling. And in the last stage, the mist extraction occurs where coalescence and polishing phenomena ensures the microscopic droplets having the size less than 10 microns meters are combined and fall back into the liquid stream. Mainly, there are four types of separators: vertical separator, horizontal separators, spherical separators, and filter separators. Vertical separators are suitable for higher purity of gas liquid mixtures, while horizontal separators are suitable for gas, liquid, and oil contents. Spherical separators are suitable for gas, liquid, oil, as well as solid contents, while the filtered separators are suitable for those streams which have fine droplets having size less than 10 microns meter. Separators are selected based on multiple criterias. Just like vertical separators are ideal for those fluids which have high gas to liquid ratios and high sand or solid contents. They have better ability to handle the surge but are critical for level control. And vertical separator are suitable for compact installations and are easy for maintenance. But the vertical separator are not suitable for the mixtures that have capability to generate foam. Horizontal separators are ideal for fluids with high liquid to gas ratios, but they requires the surge volume and they are easier for level control. Horizontal separator have larger footprint but they are easier for internal access. and they are also suitable for those mixtures that have capability to generate foam. While spherical separators are preferable for those mixtures that contain solid contents, and they have better capability to surge handling for both gas and the liquid. Spherical separators are suitable for low capacity separation. They are compact, lightweight, and easy to install. Filter separators are ideal for those streams which have very fine liquid droplets. They have high separation efficiency and they are suitable for those microscopic droplets whose size is less than 10 micron meters, just like candle filters and the wire mesh type filters. But they have higher replacement and the maintenance cost. In the sizing steps of separators, first step is to calculate the drag coefficient of liquid droplet. And in the second step, we calculate the terminal velocity using droplet dia, density of liquid and gas, drag coefficient, and gas viscosity. In third step, we calculate the separator diameter and liquid holdup height. In fourth step, seam to seam length and slenderness ratio is calculated. In fifth step, the dataset is developed using multiple retention time, say from 1 to 3 minutes. And in the last step, we select the suitable size of separator from GPSA standards. GPSA is the Gas Processing Suppliers and Associations. In continuation to the sizing steps, we determine the drag coefficient, which is called CD, in step 1 using iterative procedures, and then in step 2 we calculate the terminal velocity. In next steps, we calculate the gas capacity constraint and the liquid capacity constraint for vertical or for horizontal separator using these formulas. Moving on, we calculate the set of values using different retention times from 1, 2, and 3 minutes. We calculate the set containing diameter of the separator, height of the separator, seam to seam length, and slenderness ratio. But for the horizontal case, horizontal separators, we have to also calculate the effective length. Effective length is basically that zone of a horizontal separator where the drag coefficient is overcome by the gravitational force and the droplets starts to fall down into the liquid holdup volume. After completion of all the sizing calculations, we use the GPSA standard to finally estimate the separator size. For example, if retention time 3 minutes and the diameter we found 36 inch and the liquid height 38.6 inch and seam to seam length 9.6 feet while the slenderness ratio was 3.2. In this case, the recommended separator size becomes 36 inch by 10 feet vertical separator. Similarly, based on the other retention times and on the basis of our requirements in the complete process, we select the right type of the separator dimensions. These are the nomenclature used in the GPSA standard. For the mist eliminators, there are mainly three types of mist eliminators which are used in downstream of separators. First one is the wire mesh demister. The wire mesh demister has capability to remove 10 to 100 microns meter droplets, and it create pressure drop of zero point 0.5 to 1 psi. It is best for the general service and it has a low cost and low pressure drop, but it is easily can be scaled and fouled during the process. Second is the vein pack demister. The vein pack demisters are very suitable for those droplets that have size from 5 to 50 micrometer, and these demister create a pressure drop of 1 to 2 psi. They have a high efficiency and they are compact and the self draining ability, but their pressure drop is very high. Third is the cyclone or centrifugal separators. Cyclone separators are best used for the dirty gas or where there is a high liquid ratios in the streams, and they also are used where there is no fouling phenomena occurs or it has capability to retard the fouling inside the separator, but their pressure drop is very high side. For selection of the packing inside the separators, a general rule of thumbing is used, and that is K factor. K factor is vital for selection of packing inside separators, and it dictates that how fast gas can travel without carrying liquid droplets and moves out of the separator. In this graph, reference from the GPS standard, you can see that if there is a very high pressure and the low K factor, then there will be the no requirement of the demister pads or the demister pads will not be suitable. And here the orange line reflects on the graph. But if the operating pressure is lower side and the K factor is higher side, then the wire mesh pad, demister pads is suitable inside the separator. The K factor is not fixed. It depends upon the process and the process parameters like pressures and the fluid properties.